Have you ever thought what it would be like if you could instantly affect something light years away from you? Imagine if, like a pair of cosmic twins, two particles, no matter how distant, could influence each other. You might think this is pure science fiction, but in the realm of quantum physics, such strange phenomena are not only possible, they are a reality. Intrigued? Well, brace yourselves as we delve into the mesmerizing and sometimes perplexing world of quantum entanglement. So let's dive into the fascinating world of quantum entanglement. Imagine you have a pair of dice. Now, think of each die as a particle in the quantum realm. These dice, much like quantum particles, have a unique property. They're entangled. To understand entanglement, let's play a game. You roll the two dice, one after the other. The first die lands on a 6. Now, without looking, can you predict what number the second die will land on? In our everyday world, that's impossible. The outcome of the second roll is entirely independent of the first. But what if these were quantum dice? In the world of quantum mechanics, these dice, or rather particles, behave peculiarly. If they're entangled, the moment you roll one die and it lands on a number, the other die, no matter how far apart, will instantaneously know what number to land on. It's as if the dice are communicating at speeds faster than light, breaking the cosmic speed limit set by Einstein's theory of relativity. It gets even weirder. Until you look at the first die, its outcome isn't set. It doesn't exist as any one number but as a superposition of all possible outcomes, 1 through 6. It's only when you observe it that it collapses into one definite state, and the moment it does, the second die, irrespective of the distance, instantly settles on its correlated number. In the grand cosmic casino, quantum dice don't play by the rules of classical physics. They follow a different playbook, one that's still being deciphered by the brightest minds in physics. So, the next time you roll a pair of dice, remember, in the quantum world, they could be entangled, each roll mysteriously connected to the other, the outcomes intertwined in a dance choreographed by the strange laws of quantum mechanics. In the quantum world, this is exactly what entangled particles do. Now, you might ask, how does this happen in real life? Well, let's take a walk through the quantum realm, shall we? It's quite different from the world we see around us, but it's equally real and incredibly fascinating. In this realm, we meet our key players, quantum particles. When two such particles interact, they can form a special bond, a quantum entanglement. This bond is a little like a friendship, but unlike friendships in our everyday world, this bond isn't affected by distance. Whether these particles are inches apart or light years away, they remain connected. It's as if they've made a pact to mirror each other, a pact that not even the vast expanse of the universe can break. Now let's imagine we measure one of these entangled particles. In the quantum world, things can be in a state of superposition, where they can be in multiple states at once, until they are observed or measured. It's like Schrödinger's famous cat, which is both alive and dead until we open the box to check. So when we measure our particle, we force it to choose a state. And the instant we do this, its entangled partner also chooses a state, a corresponding state that perfectly mirrors its partner. It's as if the first particle sent an instantaneous message to the second one, telling it what state to pick. But here's the twist. This happens faster than the speed of light, the universal speed limit, according to Einstein's theory of relativity. This is what Einstein famously referred to as spooky action at a distance. The size of the universe, the speed of light, the laws of physics as we know them, none of these matter to entangled particles. They dance to the tune of quantum mechanics, a tune that is strange and counterintuitive, yet undeniably real. This is the magic of quantum mechanics. Einstein referred to this as spooky action at a distance, a phrase born out of skepticism and bewilderment. Albert Einstein, the man who gave us the theory of relativity, had his doubts about quantum entanglement. He couldn't reconcile how two particles could be so intimately connected regardless of the space between them. To him, it seemed too strange, too spooky. Einstein wasn't alone in his skepticism. Many of his contemporaries found it hard to accept this bizarre concept. However, modern quantum physics has taken this eerie concept and proven it to be a fundamental reality of our universe. Experiments have repeatedly shown that measuring one entangled particle instantly affects its partner, no matter how far apart they might be. The most famous of these experiments is the Bell's theorem experiment, conducted in the late 20th century. The results of this experiment showed that the properties of entangled particles are indeed correlated, just as quantum mechanics predicted. This was a groundbreaking moment, solidifying the reality of quantum entanglement. So, what does this mean for us? This spooky action at a distance has profound implications. It challenges our understanding of the very nature of reality. It tells us that the universe is not as separate as we might think, that at the quantum level, everything is interconnected in ways we are only just beginning to understand. It also opens up a world of possibilities. Imagine a future where quantum entanglement could be harnessed for instantaneous communication across vast distances of space, or quantum computers that could solve problems beyond the scope of any classical computer. The possibilities are as vast as the universe itself. Even though it defied Einstein's understanding, quantum entanglement is a fundamental part of our universe. It's a reality we're still grappling with, a mystery we're still unraveling. But one thing is for certain: the universe is far spookier than we ever could have imagined. So, why does quantum entanglement matter to us? To answer this question, we need to dive into the potential applications of quantum entanglement. Just as the discovery of electricity and the invention of the internet revolutionized our world, quantum entanglement could be the next game changer. Firstly, let's talk about quantum computing. Traditional computers use bits, a binary system of zeros and ones, to process information. Quantum computers, on the other hand, use what's known as qubits. These qubits can exist in both states at once thanks to a property called superposition. And when these qubits become entangled, it creates a vast array of possibilities for complex computations. In theory, a quantum computer could solve problems that are currently impossible or would take a traditional computer billions of years to crack. Next, let's consider secure communications. In a world where data privacy and security are of paramount importance, quantum entanglement could provide the ultimate solution. It's called quantum cryptography, and it's based on the principle that if you try to observe or measure a quantum system, you inevitably change it. This means that any attempt at eavesdropping on a quantum encrypted message would immediately be noticed. But these are just the applications we can foresee. The true potential of quantum entanglement might be beyond our current imagination. Just as the inventors of the transistor couldn't have predicted the smartphone, we can't fully anticipate where the study of quantum entanglement will lead us. In the same way that understanding the atom led to nuclear power and the MRI machine, understanding quantum entanglement could revolutionize our technology, our communication, our computing, and even our understanding of the universe. This is why quantum entanglement isn't just a curiosity of quantum mechanics. It's a window into a world of possibilities that could redefine our future. The future is indeed quantum. So, what have we learned today? We've journeyed into the realm of quantum physics and explored the fascinating concept of quantum entanglement. This is when two particles become inextricably linked, forming a bond that transcends space and time. Regardless of the distance between them, even if it's light years, a change in the state of one particle instantly influences the state of the other. We've delved into the mechanics of how this works, how the act of measuring one particle immediately impacts its entangled partner. It's a process that defies our everyday understanding of how the world operates, and it's a cornerstone of quantum mechanics, the theory that governs the smallest particles in our universe. We've also touched on Einstein's skepticism of this phenomenon. He famously referred to it as spooky action at a distance. Despite his doubts, quantum entanglement has been proven to be a very real part of our universe through numerous experiments. Lastly, we've examined the potential applications of quantum entanglement. It's not just a strange curiosity of the quantum world. It has the potential to revolutionize fields such as computing and communication, creating technologies that are currently beyond our wildest dreams. Quantum entanglement might seem like science fiction, but it's very real, and it's paving the way for a future we can only begin to imagine.